In this demo, we'll see how the improvement in object detection is done and also about the mapping using depth camera D455. So first seeing about the object detection, previously we had only 435 images and trained using it. So this time they thought of training the model using benchmark datasets collected from the Kaggle website. Kaggle website is one famous website which is known for its dataset collections. So from there we took trashes and then we splitted it. So we have basically uh, yes, 7 classes: bin, cans, cups, paper, plastic, sinks and trashes. So we collected these data sets and put it together. We are having nearly you can see here there are 4192 images. So bin, these are cans, and then comes cup, and then all these are cups, bins. So these are of, you can see the variety in shape, size, color, texture, everything. All these are bins, and then metals. Metals you can take it, put it in cans, and then all these are papers, tissues, everything comes in one category, and then all these plastics, and then extra trashes, whatever it may be. So 4192 images are there. What we have to do is, after collecting the images, we have to label them. If you see here, uh, there are another folder called labels. So for each image there will be a label with this data. This one is the class number, and then followed by the coordinates of the bounding boxes which we'll put around the image. So for example, in order to create the label, we can use this makesense.ai website. So this is very helpful. Here what you can do is you can just click get started. So we can select some random images. Say I take this images. I'll take this whole image and then upload, and we are doing object detection, so select object detection. We have to create labels. Since I took only cans image, I give my label as can. You can also add more labels, but then since I have only cans here, I take that can and then start the project. What we have to do is we have to draw the bounding box for this. So draw the bounding box across this, adjust the size, cover it properly. So I have to cover the scan alone, and you can select the label here. I only have can, so you can go for can, expand it. Yes. So next image, again draw the bounding box for this alone. Again, since I previously selected can, then automatically it will select it as can again the same can. So once I label all such 4000 images, that's all. You can go here in actions, you can export the annotations. So since I'll be using YOLO, I'll take this and then you can export. This is how we have labeled all the 4000 images, and these are again 4192 labels are there for each images. And then I split the data into train and validation. Validation you can also say it as test. Similarly, labels again train and test data sets. So after that, here is the way to train the YOLO V5 model. So after importing, we'll upload the file here. So once uploaded, we can train it here. See training. So I gave 100 epochs, 100 epochs, 100 iterations and trained, and then the weight files will be saved. The weight files are saved. So you can download this weight file and you can train. Let's see, let's test the weight models now. So here, I'm running the script now. You can see that I have set the confidence as 0.45. So in the dustbin, since if it finds that confidence is more than 0.45, it will put the bounding box. First I kept the dustbin, so it is detecting with the accuracy maximum of 0.6 and 0.7. Then I kept paper. So initially it will take time to come to a steady state. So once I place the paper, then it detects with the constant accuracy around between 0.6 to 0.72. And then I'm placing cups. So again, initially it will take some time to detect, and once it's all set, and then the cups is displaying with the accuracy around 0.6. When I move the dustbin, so even if there is some change in the position, again it takes some time and then it goes into the steady state of 0.87 and 86 or 84 is the maximum. And then I'm placing a paper and then a cup, a small cup, again it directs with the same accuracy. The detector, the paper, sink, so all these are here. So before previously the dustbin was of accuracy 0.81 and then now it has been as 0 again, which is of same accuracy. Can we were not able to detect can, so this is yet to be trained. And then the cup, so the accuracy has been increased to 0.82. Similarly tissue, which is now paper, 0.90, and then the base ink was 0.60 and now it is 0.51, which means still more it has to be trained according to the sink we have. So the dataset doesn't have sinks of such type, so you have to be also sure of all those, and then all these have to be trained. So more number of iterations are yet needed in order to cover all the 7 classes. Previously there were only 5 classes. So this is all about the object direction. Next we'll see about mapping using depth camera D455. So currently I'm scanning the kitchen of my house. So we'll be creating a 2D mapping of the kitchen. So this depth camera is working based on the frames, and it will connect to the consecutive frames, and then it will take the obstacles with the IR sensor which it is having in it, and then it will be mapping it. So now I'm ready to run my script now. To get the mapping, I'm selecting the map topic. So yes, currently I'm facing towards the front door of the kitchen. I go around the kitchen and then I turn my camera and I'm trying to map. So the free space will be marked in white color and all the obstacles are mentioned by that black color dots. So all such dots, the pixels uh, form form this map. So then when I turn around the kitchen, so the free spaces are marked and the obstacles are marked in the black color. So once I lose the track of my frames, I go back to the previous position from where I left, from where the camera was lost, the frames were lost. From there again I start scanning now, and again I got track of that frame. So now again I turn around, and then I yeah, form the final map. Once mapped, now we can go ahead and save the map. For that I'm using map server. I'm giving the name as kitchen. This is a saved map. You just zoom in, and this map we'll be using it for localization and then the navigation for the autonomous navigation part. So this is the another place where we have mapped. This place is IC lab in our college. Uh, so we can see the real image. This is the real image where we are having chairs and all in between, and around there are tables placed, right? So when we are trying to map this world, so this is the map that we get. So around there are tables, and in between there are these the chairs that we have put. So for another similar view, we can say another image here. This is the that spatial view. So that space is this corresponding space. And now another image is this from the behind view. So there are teacher's table in front and then door. So here if you see, that is the door, and then the table that we have seen and all those different teacher's table. So this is the map of that entire IC lab that we have created. So similarly, we can create the map of any space and use it for the localization and mapping. Thank you.